Hello, this is Doug Tidwell. I was recently sitting in my corner office admiring the scenery through my floor-to-ceiling windows when a friend called and asked when the next IBM Cloud intro video would be ready. I said, "I'm posting it right now, Mr. Roethlisberger," and here we are. In the first video in this series, you built a simple Node application with a continuous delivery pipeline and a Cloud NoSQL database. In the second, you took a more advanced version of that application, tied it to your database, and deployed it both locally and in the cloud. Today, you'll move into the world of containers with the same advanced application. You'll build a Docker image from your code, run that Docker image on your machine, then push that image into the cloud and run it there. Before you get started, we assume you've gone through the second video, installing the required tools and cloning the GitHub repo so that the advanced app is on your machine. At the command line, switch to the DWTV Advanced App Directory now. But first, by law, any discussion of containers must contain a picture of a cargo ship loaded down with containers. That completes our legal requirements. We hope you enjoyed this photograph as much as we did. Off to the web to install the tools now. First, you'll install Docker. Head to docker.com and download and install the Community Edition. If the install tells you you need to reboot your machine, wait until after you have Kubernetes set up before rebooting. The next step is to create a Kubernetes cluster and install the tools to work with it. Go to the IBM Cloud console, select the menu in the upper left, and choose Containers. When you see this panel, click the Create Cluster button. When you see this panel, give your cluster a name. I called mine Mailbag. We're using the free plan by default. Be sure that's checked, the price is right, and then click the Create Cluster button. While your cluster is coming online, click the Kubernetes CLI link to install the Kube Control tool. Follow the instructions for your platform. It may be a while for your cluster to come online, so focus your attention on Docker in the meantime. So it's command line time. First, use the Bluemix login command to authenticate yourself. Once you're logged in, you need to install the command line plugins for the container service and the container registry. So type bx plugin install container service -r Bluemix, then bx plugin install container registry -r Bluemix to install the two plugins. Finally, type bxcr login so you can work with Docker images in the IBM Cloud. Next, you need to start Docker. If you're on Windows or the Mac, use the icon to start Docker. For Linux, you probably use System Control Start Docker or Service Docker Start. Check the documentation for your distro. Whatever your platform, you'll have to wait a few seconds, but the Docker service is up and running. Before you build your Docker image, let's take a look at the Docker file. The first line, the from command, tells Docker that you're basing your image on the latest IBM Node runtime from Docker Hub. When you build the Docker file, Docker will download this image if it hasn't been downloaded already, then run the rest of the commands in the file. In a nutshell, the rest of the file creates a working directory, installs the NPM packages your app needs, exposes port 8080, copies all of your code into the working directory, and tells Docker that node app.js is the command to run when you create a container from the image. So go to the command line and build the Docker image by typing docker build -t webinar :v1 dot. The -t gives this image a tag. That's how we'll refer to the image later. The image will be named webinar, and we're calling this version v1. The dot tells Docker to look for the Docker file in the current directory. The first time you run this command, it will take a few minutes as Docker downloads the node image. If you've run this command before, it will only take a few seconds because Docker has a local copy of the image's dependencies. Now your Docker image is ready to run, with one exception. Your code doesn't have the credentials it needs to access the database. Your code includes a Docker ignore file that tells Docker not to put the .env file into the image. For security reasons, that's a really bad idea. You don't want sensitive data in your image. What you'll do is specify the credentials as a command line option when you create the container. Look in the .env file you created in the second video and copy the value of Cloudant URL to the clipboard. The format of the URL is username, password, @, then the actual URL of the service. This lets you specify everything your app needs with a single environment variable. And the moment you've been waiting for, probably, you get to create a Docker container with your new image. Type docker create -e Cloudant URL, no space, =, no space, paste in the value of Cloudant URL, then the name of your image, webinar :v1. You'll get a long hex string that identifies the container. But how do you access the container? You'll do that through the magic of the awesome Kitematic tool. Go to the menu bar on the Mac or to the system tray on Windows to launch Kitematic. You'll have to install Kitematic separately on Windows. Be sure to follow the instructions carefully. Now let's go to Kitematic. On the left is a list of your containers. Each one has a randomly generated name. Click on the name, then click the Start button if it isn't running already. Now go to the Settings tab. You can see a list of the environment variables for this container. Cloudant URL is in the list. To set up access to the app running inside the container, go to the Ports tab and assign a port number on your local machine. This maps the port you exposed in the Docker file, 8080, to a port on your local machine. We went with 32,000, but it can be any unused port. Click Save, then go to a browser and open that URL. You should see your containerized app running like a charm. A side note, Kitematic isn't available on Linux at this time, but we highly recommend Portainer. Visit portainer.io for setup instructions. Just as you did in the second video, check to make sure your code actually put your data into the cloud database. Go to the dashboard in the IBM Cloud console, click on your database service, click the Launch button on the Services Management page. Look in the webinar database and you'll see the JSON document your container just created. At this point, you've built a Docker image from your code and configured and deployed a complex application on your machine. Although it's running locally, it works with your Cloudant database in the cloud. Your next task is to create a Docker container in a Kubernetes cluster. Your first step on the road to Kubernetorial dominance is to make sure your cluster is running. Go to the IBM Cloud dashboard. You should see your cluster in the list of clusters, and ideally a green light and the word ready next to the name of the cluster. If that's true, you're all set up. If not, wait until the cluster is running. Feel free to get up and stretch or have a refreshing beverage in the meantime. Now back to the command line. The first thing you need to do is add a namespace for your Docker images. You'll use the namespace in your image names. You'll see that in just a minute. The command is bxcr namespace add followed by whatever you want to call your namespace. In a burst of creativity, I decided to call mine Mailbag. With the namespace created, you can use the Bluemix command to build a Docker image directly into your private registry. The command is bxcr build-t, then the name of your image. Notice that you have to type the address of the IBM Cloud region you're using, then your namespace, then the name of the image, and a tag for that image. You'll create a v1 image here. After several seconds, the image is built in your cloud-based registry, as the bxcr images command clearly shows. That's one way to do things, but you can also take your local image and push it into the IBM Cloud. First, you have to use the Docker tag command to tag the image. Notice that you start with the current image name, then create another name as you did earlier. In this case, use v2 as the tag so you can keep the two images separate. The tag command only takes a second. Now you can use the Docker push command with your new name to push the image into the cloud. If you like, you can view your images in the cloud from the IBM Cloud console. Go to the Containers menu, expand the Registry tab, then click Private Repositories. You'll only see one image name here, but that's because you've stored two versions of the same image. Click on the image name and you'll see both v1 and v2. Now that you have your Docker images stored in the IBM Cloud, it's time to move to Kubernetes. Type bxcs cluster config mailbag, if your cluster is named Mailbag, to get the credentials for your cluster. The output of the command includes the details you need to configure the kube control command you installed earlier. Copy and paste the output from the cluster config command and you're ready to go. When you set the kube config variable, kube control uses those credentials to access your cluster running in the IBM Cloud. Be aware that those settings only work for the current command line. If you switch to another terminal, you'll have to define kube config there as well. And aside, there is amazingly little consensus in the Kubernetes community as to how kube control should be pronounced. Popular variations include kube control, kubectl, kubicuddle, and latrell. Say it like you feel it, but we'll use kube control here. Thanks for your understanding. To set the Cloud URL environment variable for your container, you need to create something called a Kubernetes secret. As before, copy the value of Cloud URL from your .env file to the clipboard. One complication of a Kubernetes secret is that the values of the credentials have to be base64 encoded. If you're on Linux or the Mac, encode the secrets with echo-n, the value of cloud URL in double quotes, then pipe that into the base64 command. "-n is important because it doesn't include a new line after the text. If you're on Windows, you'll need to use one of the many base64 encoding tools available on the web. By the way, Windows includes certutil, which can do base64 encoding, but it always includes the new line character in the data, so it won't work. At any rate, once the value is in base64, copy it to the clipboard and open the webinar secret YAML file. This file gives the secret a name and defines the credentials you want to store. Paste the encoded value into the file and save it. Back to the command line. Type kubectl create -f webinarsecret.yaml. This creates the secret. Next, open the webinar deployment.yaml file. This sets the name of the deployment to webinar. Make sure the image name, port number, and environment variables are set correctly, then save the file. To deploy your image to Kubernetes and create a container, type kubectl create -f webinar deployment.yaml. Now you've got a secret defined in your cluster and you've deployed your container to the cluster as well. The next step is to expose your cluster to the outside world. Type kubectl expose deployment webinar --type equals node port --name equals webinar service --port equals 8080. Now you've got everything up and running. You just need to figure out the IP address of the cluster and the randomly assigned port the cluster uses to expose your app. Kubectl describe service webinar service gives you the port number within Kubernetes, and bxcs workers mailbag gives you the IP address of the cluster itself. Go to a browser, combine those two values into a URL, and you'll see your running app. Remember, this is running live on the web, so anyone in the world can see your handiwork. Fill in the form, click Submit, then go back to your Cloud dashboard to verify that your app updated the database correctly. So you've deployed a Docker container inside a Kubernetes cluster and tied the app running inside that container with a cloud-hosted database. With your newfound skills, brace yourself for excited coworkers showering you with praise, proposals of marriage, and offers of free drinks, or something like that. You've taken two more major steps toward complete cloudular domination. Including the previous two videos, you know how to create an application locally, deploy that app to the cloud, package the app as a Docker image, and push the Docker image into a Kubernetes cluster. In the final video in this series, you'll use a completely different architecture to update the database using a small app that interacts with a microservice hosted in the IBM Cloud. But we'll stop for now. Thanks as always for watching. I hope this video was helpful. Until next time, this is Doug Tidwell saying may all your bugs be shallow. Cheers.